All right, so we're going to talk about mean. What is mean? We're not talking about being mean. We're talking about something very different, okay? So in statistics, I'll normally say the mean instead of the average. This is really all that we're talking about when we say mean is the average for the value. So you may be asking, well, why don't we say average? Well, when we say mean, we have a slightly different connotation to what we're talking about. So we use a slightly different terminology. Mathematically speaking, when we deal with central tendencies, one of the central tendencies is the mean or the average that we're looking at. Okay, so that's just a terminology issue. Don't worry about too much of that. I will occasionally use those two words interchangeably, and for the most part, they are more or less interchangeable. Okay, they are found the exact same way as well. So let's just kind of go with that. So, and the other reason we use mean is that sometimes when we say average outside the world of mathematics, we're not really talking about a mathematical average. So when we say mean, we're only talking about the mathematical average or the mathematical mean. Okay. We have two symbols here that we need to talk about. First one is Xbar. Xbar is the mean, and we'll write down the mathematical version of what this looks like here in just a second. When we say Xbar, we're talking about the mathematical mean. This U-looking symbol right here is actually mu, okay? And you can call it U if you want to, but it's mu, M-U. It is a Greek symbol. It looks just like the letter U written in cursive. This is approximately X bar. Now let me kind of explain the difference of what's going on here with these two pieces, and this kind of leads us into another aspect of some stuff that we need to talk about. Namely, this is the mean for the sample population. This is the mean for the population. Now let's take a quick discussion about what the difference is between those two things. When we talk about the mean for the population, we're saying we want to measure some type of quantity of some sort. Let's just say that we want to determine how many people eat red meat on a daily basis in the US. Well, there's no real way for us to, I guess there is a real way for us to do this, but it would be massively time consuming. How do we figure out what is the average number of people who eat red meat on a daily basis is? What does that value look like? Well, we'd have to go out and ask every single person in the United States if they ate red meat today. All right. We're talking about 350 million-ish people or so. We can't really do that. I guess we could, but how would we accomplish that in a timely manner? It's just that's a lot of data to collect. Even just one question, you're talking about an enormous amount of data to collect in a very short time period to make it accurate. So we can't really do that, which is why we have an estimator for the mu. Okay, so X bar is, and I'm taking a little bit of liberty here with this definition, but X bar is essentially the estimator for U. This is our mean for our population. This is the sample mean for our population, or the mean for our sample population. And when we say sample population, what we're talking about here is a group of the population. Okay, and actually I should put the word subgroup in front of that. It's a subset. All right, so when we talk about sets, we're talking about a collection of objects that all have something in common. If we're talking about doing a sampling from the U.S. population, we're talking about going out and asking so many hundreds of people or so many thousands of people, hopefully doing it very randomized, and the more random we do it, the more accurate it theoretically is of the overall population. We're going to talk more about this idea of how big our sample size needs to be in order for it to be accurate. It's actually quite low of a number, even for a population of 350 million. I think of the population is somewhere around 330 or 340, but that's where we can kind of look at that number. It's not as huge a deal. That when we talk about asking everybody that question, it becomes a very daunting task. We're talking about measuring it for a subgroup, it becomes far more attainable. Now the problem is that this is a estimate. It's the average for this subgroup. It's not necessarily the average for the entire group, so it might be off a little bit. Let's just say that 65% of the people eat red meat every single day. I think that'd probably be pretty high. But let's just say that is what it is for a second. It doesn't mean the actual population is exactly 65. It might be 63, maybe it's 67. So that's why we have this separation between these two, is because this X bar is a representation of mu, but is not an exact value for mu. And we can't necessarily figure this value out. So anytime we need to know a value for mu, we're going to use X bar as that value for mu when we do our calculations. So keep this in mind, that when we go through statistics, a lot of times we're dealing with things that are estimates of estimates. And that's really the best we can do with it. And what we try to do is minimize the amount of error and bias and all these other pieces that go into this, which actually brings up some other terminology we should talk about. When we say bias, I don't know if I wrote that right, but anyway, what we're talking about is the idea that there is some type of error in the data collection. Okay, and when we say error, we're not necessarily talking about wrong. Okay, we're not saying it's wrong. We're not saying that we did something incorrectly or that our data is worthless or anything like that. When we say bias, we're talking about there's some error that is in our data collection process. And there's really a whole lot that we can do about that. We can minimize our bias, but we can't eliminate it entirely. So let's just say that we're going to go out and ask this question to a group of people. Well, how do we pick our group of people? Are we going to randomly pick people out of a phone book and start calling people? Well, 30, 40 years ago, that would have been a pretty straightforward way of doing that. You just randomly pick some people's names in the phone book. You open the book and you turn to a page and you pick somebody's name. How do you randomly pick a name? How are you doing that? Do you just pick one person in each page? Well, how are you doing that? The problem with that doing now is that there are a lot of phone numbers that no longer appear in phone books because so many people do not have a landline anymore. They have just a cell phone. So that number doesn't necessarily appear in a phone book anywhere for you to just go pick it out. So you can't just do random calls, thereby increasing the amount of bias or the amount of error in that data collection. So we're bringing in, now this does happen as well, we're not necessarily bringing in saying, oh, I'm only going to ask people with curly hair. Well, okay, fine, ask people with curly hair. That is a bias. That's a most definite bias. And if you're unaware that you're only asking people with curly hair, then that's an issue that you have to deal with because you are introducing error into your data collection. But if you are just doing your data collection as randomly as possible, and that's the idea here, is we want this data collection to be random, then as long as it is as random as we can possibly get it, then that's as good as we can do. It doesn't mean that the data doesn't have some type of error or some type of bias in it. It just simply means that we are trying to minimize that bias as much as we can by randomizing our data collection as best we can. And there are lots of ways that we can randomize our data collection. And the idea about it, by it being random, that's a whole other issue as well, is that, well, what does it mean for it to be random? Random means there's no order or process or rule in how we're picking our values. If we were asking people questions, there'd be no way there's no process about how we're asking people the questions. We're just simply going out and asking the question to random people. How random can you really be, though, right? You're just calling people on the phone randomly. Well, how random can that really be? Rolling a dice, that is a completely random process. There is no rhyme or reason to what is going to land, what face is going to land up. Same thing with flipping a coin. There's no that is a completely random process. There's no rule that regulates whether heads or tails is going to come up first. Some people think that's a really interesting topic because there are actually people who believe that heads is going to appear first or tails is going to appear first, or that whatever appeared first is what's going to appear next, or whatever appeared last time you flipped the coin is what's going to appear next. So some people do believe that there are rules to things like that, but they're not. And that's the idea about it being random. A random event is something that is not predictable. That by its very nature means it is unpredictable. Okay? It's unpredictable. We don't have a rule. Okay? Now let's think about when you're collecting data. How do you really create a situation where it's completely unpredictable and there's no rules about how you ask that next question to a person or how you collect that next piece of data? How do you do that? How do you keep that completely random? You really can't. This is not flipping a coin. This is not rolling a dice. So you are going to have bias in your sample, okay? And that sample is a subgroup of your actual population you're concerned with. This isn't necessarily people. It could be just about anything you're collecting data about, but your sample is a subgroup, and the way you collect that subgroup is going to hopefully be as random as you can get it, but there are limits to how we can do that. Hence the reason why our mean, X bar, our sample mean is what this is right here. This is our sample mean, is another way to describe this value. Is going to be an approximation of our population mean. And the reason for that is those topics that I just discussed. Okay, in the next video, we will talk about how to find this sample mean. It is quite straightforward. All right, thank you.